All right, it's chapter 6, and this is Mrs. Stipe, and we're going to talk about quadratic functions today. And a quadratic function is a function in the form f of x equals ax squared plus bx plus c. And the only requirement here is that a can't equal 0. All right, so today specifically we're going to solve quadratic functions, and we're going to use factoring as our method. It's not the only method, but it's the one we're going to focus on today. So just to make sure you understand, when I say solve, I'm saying find the x-intercepts. So let's talk a little bit about the graph of a quadratic function. It makes a shape called a parabola. All right. The x-intercepts are these two places in this case where the graph crosses the x-axis. And the way we find x-intercepts for any function is we set y equal to 0. All right, so that's what we're going to do, and I'm just going to show you different types of problems that you'll run into that will that you'll have to solve. Okay, so we'll start out with some super easy ones which have already been factored. So sometimes I tell you to solve a quadratic and I've already done the heavy lifting for you. So this one has already been factored, and so we just simply need to find the solutions. And so in order to do that, we have something called the zero product property. And you're familiar with it. Let me just go ahead and remind you. The zero product property says if I have two factors, a and b, and when I multiply them I get 0, then one or the other has to be 0. So what we're saying is that in order to multiply to 0, the only way to do that is that if one or the other factor is 0. So here's what we've got, two factors, here's a and here's b, and so the way we finish this is we draw a t and set each of them individually equal to 0. So my solutions are 2 and 9. Okay, sometimes when we have this situation, they aren't factored yet and we have to factor. So the purpose of this video is not to teach you how to factor. We're going to in class do a lot of practice reviewing factoring with you. So I'm going to go through these factoring examples pretty quickly. Hopefully you can follow along, and if not, go back and look at them over again and ask a lot of questions in class. So here's an example of one that's not factored yet, and this is a greatest common factor question, and so sometimes we get something like this. All right, and to solve it, again, the directions are to solve, and so greatest common factoring means we look at the two terms and we ask what is the factor that goes into both x squared and negative 5x, and the answer is x. Same thing as above, we're going to set each of them equal to 0. Okay, and so with greatest common factoring, one side is already completed, the other one, when we solve, we get an answer of 5. Okay, sometimes we don't have the problem set up right. So let's go ahead and try this one. What if we have, and we'll make it a little bit more challenging, 3x squared minus 4x equals 4, and again your directions are to solve. Well, in order to factor, we have to start out setting it equal to 0. So we're going to move everything over to the left. Okay, like that, and then we're ready to go. And whenever the leading coefficient, that 3 there, when it's not equal to 1, we can't, it's just a little bit more challenging. We call it the guess and check method. Nobody likes this method because sometimes our guesses are wrong the first time and we have to go back and guess again. The way we start this out is we look at 3x squared and we ask ourselves, how do we multiply to 3x squared? Well, that's 3x and x. We want to multiply to negative 4 here. And so we're just going to try. When we think of negative 4, we think of 2 and negative 2, or maybe 4 and negative 1, or maybe negative 4 and 1. So these are our choices. So I'm just going to guess. I know the answer, so I'm going to guess right on purpose. And the thing about guess and check method is it doesn't work unless you actually check. And so the outside turns out to be negative 6x, and the inside turns out to be 2x. And negative 6x plus 2x gives us a middle term of negative 4x, so we know we have the right terms, the right binomials. So we're going to go ahead and now set each of these equal to 0. That's not what I meant to do. So 3x plus 2 equals 0, so x equals negative 2/3, and then x minus 2 equals 0, and x equals 2. Okay, so these are all examples of problems where you have to factor first and then solve. Sometimes we work backwards, so let's try this one. If I tell you the solutions to a quadratic are 7 and 3, your job is to find the quadratic. Okay, and so what you would do is you would do this procedure backwards and say if the solutions are 7 and 3, then I know the factors are x minus 7 and x minus 3. Okay, does that make sense? If the factors are x minus 7 and x minus 3, the solutions are 7 and 3. And so this time, instead of solving, we're going to go ahead and multiply, double distribute, or FOIL, whatever it is you call it, and we get x squared minus 10x plus 21 is our quadratic. Okay, hopefully that makes sense. Let's try one with a fraction because that can be tricky. So the solutions are negative 5 and 1/3. Okay, so negative 5 as a factor seems pretty easy. That's going to be x plus 5. 1/3 is a little trickier. We need to think of a factor that when we set it equal to 0, we get x equals 1/3. Okay, and so the denominator turns out to be the leading coefficient of the x, and the numerator is always the opposite of the constant. All right, so if 1/3 is the solution, 3x minus 1 would be the factor. And then we would simply multiply this out and get 3x squared plus 14x minus 5 would be our quadratic. Okay, let's see how I'm doing on time. Oh, pretty good. All right, so last example I want to do is a type of factoring that we have not done, you haven't seen in a while, and it's called the substitution method. And there are some problems that in the homework we're going to do in class that you'll have to do this. So let me just give you a real quick example. If I have x to the 4th minus 3x squared plus 2 equals 0, this is no longer a quadratic equation. We have a fancy name. It's called quadratic form of an equation, but not a quadratic equation. All right, and so the way we solve this is we do something called u substitution, and if we say u is equal to x squared, then this becomes u squared minus 3u plus 2 equals 0. Okay, does that make sense? U is x squared, so x to the 4th is u squared, negative 3x squared is 3, negative 3u, and 2 is 2. So this one's super easy to factor. I put a u and a u, a minus 2 minus 1. Okay, so I go ahead and I solve. I get u minus 2 and u minus 1. Right? So u is equal to 2 and u is equal to 1, but I don't want to solve for u. I want to go back and plug in, substitute back in the x squared. So if x squared is equal to 2, x is equal to plus or minus root 2. And if x squared is equal to 1, x is equal to plus or minus 1. And later on we'll learn the theory about why it makes perfect sense that I have actually 4 solutions to an equation where the power, the highest power, the degree of the polynomial is 4. Okay, that was a lot of information. Think about that when you come into class tomorrow. We'll go ahead and do lots of practice, and hopefully you'll do really well on this section. See you in class.